So my name is Laurynas Marcinkus. I'm the lead architectural engineer at the company Lauryna. We are a manufacturer of prefabricated straw panels. And today I think I will also introduce a little bit more what are those panels, what actually they are, and just to give you the context about this. Thanks, Mike, for also a lot of information already about what is straw, why it's so good to build, and I will try to supplement you with more information for now. So first of all, trying to think about rebuilding Ukraine green. The war started and it was Russian aggression. It's like soon after a few months, we already started thinking, okay, it will be rebuilding of Ukraine on a massive scale and how to do it. And in the beginning, we already know that, okay, straw might be one of the key elements how we could rebuild Ukraine in a fast and really good manner. So just zooming out, first of all, um, uh, we have, Mike also mentioned, it's climate change. It's a huge thing happening all around the world. And we also need to tackle this thing. It's droughts, extreme weather conditions, heat and cold waves, and so on. So we need to do something as a species, human species on Earth. Because the trend is not going really good, and we need to do something about it. The CO2 emissions is the thing, the gases causing the global climate change, something what we can do about. There are things we don't control, and this is something we could control. And building sector is responsible for around 40% of total CO2 emissions globally. So that's a big thing. And European Union as a whole, it's like 10% in the world. And Europe has pledged to really high standards or the goal to become a climate neutral continent in the world, first climate neutral continent in the world by 2050. And that means reducing CO2 emissions in most of the sectors. Building industry is the same, but does it have an answer right now? I would say not really, not at least on the big scale. Um, so, but bio-based materials, which has really low CO2 emissions and energy you put in those materials to create them is one of the things the most interesting to look at, the most prominent, I would say. So coming back to Ukraine, this is a field, wheat field, and it's a normal view scenery in Ukraine almost everywhere. So being straw and wheat crop production being so much of it in Ukraine, it suggests that it could be the material to build for. So and yeah, one of those things is when I'm talking about European Union and the global warming. We need to find the ways how to build differently, and bio-based solutions are one of the things. And what it's disastrous, it's tragic thing what's happening in Ukraine right now, but it gives mm, um, it gives an opportunity to do things much better. So what if we rebuild Ukraine in much higher quality than it would be done in other ways? So that could give the big example for the world, for European, for Europe, the whole Europe, how we can build differently and in a much better way. So now I'll try to tell what's the straw panels, why we think it's really good solution for Ukraine right now. So just an introduction of it. So yeah, you saw a short video how it's done on construction side, but basically it's timber frame. What already Mike was telling, and it's load bearing timber frame and straw from the fields as insulation material. This how the raw panel looks like in our factory. And what you get out of it, it's a lot of pluses. Why? And I will talk more about it one by one. But basically, it's a circular economy. It's almost nearly zero CO2 footprint. It's ecological materials. Combined with the clay, it's a really high indoor climate quality, what you will have. So it means healthy living. And also, what's really important here when we're talking about big scale building operations or rebuilding prefabricated elements, you can do the construction really fast and accurate and on a big scale. About indoor climate, so clay is a material which is very well combined with straw. Those are natural materials, and clay gives really good indoor climate. It prolongs the relative humidity, or like keeps it in between the best range for humans to live in, between 40 and 60%. It's also anti-static surface, so it creates that the dust is not moving so much in the houses. It's removing odors or changing those the bad smells. It's like air feeling always in the house. It's you can feel the freshness of air in that. Also, it's a thermal buffer. You can use night cooling passive systems. Here is a small diagram showing three different coatings. So the plaster, internal plaster, so it's clay and lime plasters, and also it's painted coat. So you have much higher up and lows, up and downs, relative humidity with paint. Then you will have with clay or lime. Of the moisture which is in the house when it's higher, and it gives it back when the humidity goes lower. That's a really a smart thing to have during the winter times when most of the houses, at least the timber frame houses, may have different ones as well. They have low relative humidity, and then the allergies comes to the people living in, and all of those things negatively affecting humans spending a lot of time indoors. Clay plaster, I showed before, that was more rounded corners and so on, but it can look completely differently. So that's also, all these pictures are clay plaster. So there is a huge variety of what can you do with clay plaster. Circular economy in this context is that straw is a byproduct from crop agriculture. You would use it for bedding for animals, or just leave it in the fields to come back to the soil. But it's a thing. But if you would use it for insulation properties, for insulation reasons, it's upcycling and giving much more of the value. And we are prolonging the lifetime of this residual waste. CO2 footprint is one of the things we're looking for when we want to tackle the climate change. So when you build with insulate with straw, that's on the right side, you kind of create a carbon sink. So you're putting your CO2 would be CO2 emissions if it's decomposing on the ground. In the fields, you're putting it into your house and locking it for at least 50, 100 years of time. Maybe after that, we have already solved some of the problems with our climate change. And fast assemblies is also, I think, crucial here because for example, in European Union, we need to renovate a lot of houses, block houses, and the rate how fast we are doing it, we are not happy about it. it will take long time in order to finish the renovations with all the old building blocks. So the same will go for Ukraine. It will be massive need for buildings, and it might take a long time unless we do it in the most fast way. So fast assembly is a thing for sure, and that's the prefabricated panels can do. Yeah, going a little bit more into what are the constraints for the panels. So for the architects, we always say, oh, don't limit yourself to anything. Thinking about your architecture, that's the primary goal. And what is possible to do with timber frame, our panels can do as well. We can have inclined edges, roof lights. We can have even the rounded walls from trapezoidal elements. So on the technical parameters, they are all there. We have done testings about what are the, for example, thermal conductivity, the flammability classes, sound insulation, and so on. We are using calibrated timber, and it's a professional way of building. It's scalable, so just needs to be there. The panel dimensions, it's 2.9. It's easier to put in the truck, but it can be up to 4 meters high, and thickness between 30 and 45 centimeters, depending what you values the thermal properties you would need to achieve on the project. We also are doing the roof panels, needed floor panels as well. The lintels are made in the way like roof trusses, so the steel plate connection plates with deep, so it can have a big spans, big opening. So that's also when I was saying like, oh, don't limit yourself to anything on the architectural side. So just create the designs you like. Some about the layers already I was telling, but what we suggest usually that's putting a diffusion open membrane on the external side, ensuring the airtightness. It's also protecting it with wood fiber board, and then it can be a mineral base plaster, blind plaster most of the time, or it can be ventilated facade, and it will look like any other modern building. Internally, we always recommend to have the clay plaster because of many reasons for making it the indoor climate much better for everyone living inside. The same goes for the roof, a bit different structural scheme would be there to have the I-joist for longer spans, but in principle that's the same. It's a timber frame. And few project examples just for your inspiration. It's mostly optimized for 1-2 story houses for the load bearing capacities, but it can be up to 3 stories, and that's even not the limit. It's in the connections you would need to do something different, but you can build taller houses as well. And also this, I like this picture that's about the clay. It's Klaipėda, that's Lithuania, the Port City State Music Theater. They have finished recently the project, and it's huge, and it's all clay interior. So the public buildings are shining as well in presence of clay plaster, and it also gives people, the society, the ability to look for, okay, now we see it's so good. I want to be living in that kind of house. And the last things about the topology, what I said, it's not completely about the small individual houses. It can be high-rise building. If you to build it with a CLT, for example, it's still a concrete skeleton, but you can put the thermal envelope around of those panels. That might be thinner, but that's a possibility. And also modular construction, which might be a thing for Ukraine to do the really fast rebuilding. So that was it. I hope I gave some good information, and I hope I can get more information for everyone who will need that afterwards. So thank you.